Hello everyone, Masman and I'm here in a new video that is on the topic of gravitation. In this video, we're going to be covering the topics that we left in a previous video that I made yesterday. That was also on the topic of gravitation. But in this video, we're going to be covering the variation of gravity due to of the shape of a mass of an object. Second topic or second concept we're going to differentiate the big G and the small g, mean the universal law of gravitation and our gravity acceleration generated due to gravity. And at the last, we're going to be talking about free fall too. Starting with the variation of gravity due to shape. In the last video, we understood that every object which has a mass has also, we can say, gravity. It has an attraction force. It tries to attract other object. If this book or this calendar is this still now, it is right now, it is trying to attract me, and I'm also trying. Yes, I also have mass in myself, so I'm also trying to attract it. But when I just drop it, it goes down. What is the reason behind that? The reason is earth, gravity, acceleration. Because earth has more mass than me, and in the last video we understood that the mass, the product of both the masses which are getting attracted towards each other, if their mass is more, the gravity will be more, the force will be more. If mass is less, gravity will be less. But second point that we should always remember while studying gravitation is that it is inversely proportional to the distance, to the square of distance from both the objects which are trying to attract each other. Let's suppose if we have this object and me, we both are trying to attract each other. If there is a, yeah, as you know that there is a distance between this calendar and me, there's a huge distance between both of us, and now it got more closer to me. So right now the gravitational force that the calendar applied at this distance was lesser, and now right now it is applying is more than the first our first stance. I hope you got it. So this was the topic which we understood in our previous video, in our yesterday's video. But now we're gonna talk about that the shape of the mass also affects a lot. Yeah, it affects a lot. We have Earth actually sorry. Actually, the shape of Earth is not circle, it's not sphere, proper sphere. It is ellipsoid. Ellipsoid. The shape name is ellipsoid. It is, we can't say it is a oval, it is ellipsoid. So at the bottom and at the top there are two poles, and at the center we have equator. So there might be distance between the center and to the equator, to the point. Let me tell you. This is the shape of Earth, ellipsoid. And as you can see that there is a distance between the pole and the center of the Earth. You can easily see that the distance between the equator and this point is more, radius is more, but here radius is less. So the attraction, we can say the gravity will be more at the poles of the Earth. The gravity, the gravitational power, the gravitational force is more at the poles of Earth as compared to the equator at the center. And at the center there are many mass, a lot of mass is present around a single mass. Let's suppose if I am standing in the center of the earth, so on my four of the sides, 360 degree, there will be lot of mass, and each mass has the property that it attracts each other mass. So they're gonna attract me. The mass at the front will gonna attract me. Mass here will also gonna attract me here and there. So then my weight will be zero. We have studied what is weight in the previous video. So that is what the shape, as the shape varies a lot. So if you have got gold, silver from poles, so when you're gonna come to the equator, you're gonna see the weight is very less. What is the formula of weight? Weight is equal to mass multiplied gravity, and gravitational force will be less. It will gonna be less. So then its proper weight, the total weight will also be less as compared to when you bought it at the poles. I hope you got it. So yeah, I was saying that my weight will gonna be zero if I'm standing in the center of the earth. The reason, the our formula of weight is equal to mass multiplied gravitational force. So at that time, the gravitational force will be zero. What is the reason behind that? Because each and every mass around me, around 360 degree, they're trying to attract me, and then the net force will be zero. So zero multiplied by mass, my mass will equal to zero, because when you multiply any number with zero, its product is always zero. That is simple math, basic. I hope you got it, what I wanted to make you understand. After this, now let's talk about G and G. Big G, small g. G, big G, is the universal constant of gravitation. We know that. But the G, small g, it is the acceleration generated due to gravity. And every mass has small g. And the constant value, we know the constant value, I told you in my last video, that is 6.67 multiplied by 10 raised to power minus 11. So this value will gonna stay as same because it is constant. If you go to moon, the constant value will gonna remain same. If you go to Mercury, Venus, any planet in the whole universe, the value will be same. That's why it is the universal constant. But a small g will gonna change because mass varies, the radius varies. I hope you got it. And it is a value of big G 6.67 multiplied by 10 raised to power 11. Whereas if we talk about a small g, its value is 9.8. It comes almost 9.7 something, but we take it as 9.8. 9.8. And while solving the numericals, we take it as 10 to make it easy, to make calculation much easier. I hope you got it. So that is G and small g. Leave that thing. I was saying that after studying the variation of gravity due to of the shape, we can now, we are able to calculate the gravity of every spherical object. How to do that? The formula to find the G is equal to gravity constant, universal constant, multiply the mass of the object divided by the radius, the square of the radius of that object. So if you have a Costco ball, any cricket ball, football, you can take its circumference, and by taking the circumference, you can easily find the radius. That is 2 pi r. We know that 2 pi r is equal to circumference. We're gonna do that all calculation by solving the equation. Then we're gonna get the radius. Radius multiplied by radius square. We're gonna keep the radius square divided the constant, universal constant, and the mass of the ball. It will be very less, and the gravity will be almost 0.001 something. 0.001 something it will be. So now let's talk about what we are left now. I think we are left with free fall. Let's take an example. I think we have covered this topic in my yesterday video, but let's do it again. When I dropped this sharpener, it went down. This is free fall. Why? It is that situation when an object only when gravitational force, when the object is getting attracted with only one force, that is gravitational force, that is known as free fall. I hope you got it, friends. Thank you very much for watching my video. I hope you understood today's topic. I'm gonna meet you in my next video. Until then, stay safe. Thank you very much.